Hello everyone, in the last video we have seen what is controllability and observability, and we have also solved some questions related to that. If you still don't get that video, I'll put a link on the description box. So in this video we will see eigenvalue, state transition matrix, transfer function in the state space. So first point is eigenvalue. Eigenvalue, location of the pole in the state space, stability in the state space, characteristics equation in the state space, or damping in the state space. These all are same. Mostly question will be asked in the form of stability in the state space, means some function or system is given, you have to check the stability of the system. So whatever is asked related to these 5 or 6, we will always care about how to find a eigenvalue. So the standard equation of eigenvalue is Si minus A, where Ai is the standard or the identity matrix, S is a eigenvalue, and A is the given matrix. So we will understand it with an example, like determine the stability of the system whose A matrix is given. By A matrix is given, we have to find the stability of the system. So to find the stability of the system, we have a formula Si minus A equal to 0. So Si, here the A is the 2 by 2 matrix, so we will put identity matrix like this, 1 0 0 1 minus A matrix. We will solve, we will get these equations equal to 0. We will find determinant of this. So S1 ye into, when we multiply S plus 2 into S plus 1, we will get S square plus 3S plus 2 plus minus 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 8. 8 go to the right hand side, it becomes equal to 8. When 8 comes to the left side, we will get S square plus 3S minus 6. Here the sign changes. When in equation sign change, that means a point is lie on the right hand of the imaginary axis. So the system is unstable. These concepts are related to Harvard's equation or Harvard table. I hope you all know how this happens. Now we'll see one more example. Like a system is given in this form, like we have already discussed the standard representation of state variable method. So a question is asked in that form. Here this is system given where U is given here. Determine the eigenvalue or stability of the system. Eigenvalue means Si minus A, we have to calculate. Let Si minus A equal to 0. We will put this in equation 1. These given like 0 0 1, here we will put the value of U in that equation. Now this part is multiplied with 0 0 1, and we also multiplied with 0 0 1. So this. Now this is calculated with this matrix. This is 3 by 1, this is 1 by 3. So 1 1 cancel, 3 by 3 matrix we will get here, and X is X1 X2 X3. Now 0 0, this matrix is multiplied with the plus V, so we will get 0 0 1 and V. Now this after that we will this here. These two terms are the same variables, but the constant are different, and plus sign is between them. So we will plus addition to these two matrices, and this 0 0 0 0, here 1, here 0 1 1 0 1, 0.5 minus 0.5 0, 1 minus 3 minus 2, 2 minus 5 minus 3. Here 0 0 1 and V matrix are here. After that we will compare this equation with the standard equation. When we compare this equation with the standard equation, we will get the value of A, and when we get the value of A, we can easily find out the eigenvalue. The formula is Si minus A, as here A is the 3 by 3 matrix, so the identity matrix is 1 0 0 0 1 0 0 0 1 minus A matrix that we will find out. So after calculating this, S is the multiply with this, S0 0 0 S0 0 0 S minus this matrix. We will get a matrix like this equal to 0. When we find the value of this, S into S plus 3 minus. So this is minus 1 plus 2 minus 2 and minus plus 2. When we solve this quadratic equation, we get S plus 1 and S plus 2. When we put these three terms equal to 0, we will get three values, 0, minus 1, minus 2. And these values either lying on the origin or the left side of the imaginary axis. So the system is stable. Now we will see one more example. A system described by the state variable method. A system is given. Now we have to check it is oscillatory, critically damped, over damped or under damped. So firstly we will find the eigenvalue like this, Si minus A. We will put 1001. A value is given from here. We will put this. Solving this we will get S plus 1 minus 1 S plus 2 equal to 0. When we solve this we get a quadratic equation like S square plus 2S plus 1 equal to 0. On comparing these equation with the standard equation S square plus 2 zeta omega n S plus omega n square, we get the value of comparing omega n value is 1, 2, so to cancel zeta omega n equal to 1. We will put the value of omega and we will get the value of zeta. Here zeta is 1, that means it is critically damped. Now one more term, it is state transition matrix. State transition matrix denoted by phi of t, and this is determined by the Laplace transform of inverse matrix of Si minus A. Means firstly we will find the Si, we will then find out the inverse of that, and whatever matrix we get we will find the Laplace transform of that, we will get the state transition matrix. So have an example, it asks in GATE 2014, like A matrix is given that we have to find the state transition matrix. Firstly we will find Si minus A, we will find by this way. Similarly we have done already 2 or 3 times. We will get an equation like this, S plus 1 0 minus 1 S plus 1 equal to 0. Then we will find the inverse of this matrix, and we know the basic of the matrix. When we have to find the inverse of the matrix, we have a method like we will first find adjoint of that matrix, then determinant divided by the determinant of that matrix. And as we know how we can find the adjoint of that matrix, we will interchange the position of this matrix, these two values, and change the value or sign of these two values. Like S plus 1, S plus 1. We will interchange it here, both are same, so S plus 1, S plus 1. Here 0 and minus 1. We will change the sign of that. Here minus 1, here the plus 1, 0, 0. And the determinant value of this S plus 1 ka whole square. So we will put this value here. We will get 1 plus S plus 1, 0, 1 divided by this. And S plus 1, 1, 1 cancel. Here 1 by S plus 1. We will find the inverse of that matrix. So our state transition matrix will be phi of t equal to Laplace transform of S minus A inverse. We will put the value of S minus A inverse. Laplace transform when we get in a basic, we know that 1 by S plus A e to the power minus t 0 0. S 1 by S plus 1 square, it is t times e to the power minus t, and 1 by S plus 1 equal to e to the power minus t ut. Now one more function, it is asked in GATE examination, like what is transfer function in the state space. So the formula we have to find the transfer function of the state space is Tf equal to C times S I minus A inverse B plus D. Here C, B, D, all we know that in the introduction part of the state variable method, they all are a matrix. So here is a question asked in the GATE examination 2018, like A matrix, B matrix and C matrix are given. We have to find the transfer function of that system. So how we can find that? We have the 4 options. So firstly we know we have to find Si minus A. So Si minus A, we will know how we can calculate this. We get a matrix like this, S minus 1 0 S plus 2. Then we will find the inverse of that, like adjacent of matrix divided by determinant of that. We will get a matrix like this. Then transfer function we have to find. Here is the C matrix. Here is the C matrix 1 0. This matrix here into B. And we have a B 0 1, D is missing, so D is equal to 0. When we put these values, so 1 by S into S plus 2, we will separate it. Firstly we will multiply these two matrices. This is 2 by 2 ratio, this is 2 by 1. We get a matrix like 2 by 1, here 2 by 1. After that here matrix 1 by S, and the C matrix is 1 0. Solving this we get like this, 1 by S, S plus 2, 1 0 and 1 by S. Then we multiply these two matrices. This is the order of 1 row 2 column, 1:2. This is 2 row 1 column. 2:2 cancel, we got a single term like 1 plus 0 1, and 1 is multiplied with 1 by S, S plus 1. We get this option, 1 by S, S plus 2. Here we will search where is the find. D is the option, here is the D. So D is the right answer. Now one more question. It is asked in GATE examination 2009. Given A matrix is given, B matrix is given, C is also given. We have to find the transfer function. Directly formula based question. Firstly, we have to find Si minus A of inverse. Then we will find Si minus A. Putting these all values, value of A, we will get a matrix like this. Then we will find the inverse of that. Inverse adjacent of that matrix divided by determinant of that. We will put in these values. We have already done before a lot more times. So we get a value like this. Now we will put these value Si minus A inverse B and C in a formula. Like this, C inverse B D. D is equal to 0 here. So A C matrix here. Inverse we already calculated. We will put the value of these here. And this is the B matrix. Again solving like this. 1 by S plus 2, S plus 3, we will separate it. Here is the C matrix, and when we multiply this matrix with the B matrix, we get a value like this. We will put and calculate this. We got 2S plus 5, S plus 3. This is 1 cross 2, this is 2 cross 1. We get a single value, 2S plus 5. And here is the value 1 by S plus 2, S plus 3. When we multiply these two, we get a value like this, and we can find it easily. Where is the 2S plus 5, S plus 2, S plus 3, 2S plus 5, S plus 2, S square plus 5S plus 6. So this is the right option. So here we have done eigenvalue. Firstly we will get eigenvalue, it also known as the stability of the system. Then we have discussed how we can calculate state transition matrix, and lastly we have found the transfer function in the state space. These are the some major concept in GATE examination and related question to that. So be prepared, and if you don't watch my last video, I'll put a link of that video in my description box. You can watch this by clicking that video. Thank you so much.